So in this tutorial we're going to look at writing equations. So we're going to look at word equations really briefly and then move on to symbol equations and then look at how we can balance symbol equations as well. So let's start with a word equation. I'll show you a reaction and how we can turn that into a word equation. So here we've got magnesium ribbon. So it's a strip of magnesium metal and it's burning in oxygen. So it's been heated until it starts to react with the oxygen around it. It burns with a really, really bright white light. So you might have seen this reaction before. The reaction's just coming to an end because we've got no magnesium left. We've now actually got this white stuff, which is magnesium oxide. The magnesium oxide is very, very different to the magnesium and the oxygen that you started with. So in this reaction, we've started with magnesium metal, reacted it with oxygen gas, and now we've made this new compound, which is, if you could knock it, it would become like a white powder, called magnesium oxide. So let's write a word equation for what we've just seen. So we started with magnesium, which is a metal. We reacted it with oxygen, which is a gas in the air. So if you burn anything, it's typically reaction with oxygen. And we have made magnesium oxide. So to say that magnesium and oxygen turn into something else, I have to use an arrow symbol to say it turns into, and then I can put the product, which is, magnesium oxide. Okay, so there's my word equation. And I just want to highlight a few key features of the word equation before we go any further. So everything that is on the left-hand side of my arrow, so that's these chemicals here, these are the things that react together to make the product, so these are known as the reactants. So you could be asked, what are the reactants in this chemical reaction? And it's always the stuff that's on the left-hand side of the arrow. It's the stuff that's reacting together to give you your final product. So this is your product. Okay, so there are two key terms that you need to know. We've also got symbols, so we've got plus. You can have pluses on both sides of the equation, depends on where you've got more chemicals. So you always need a plus symbol in between things that you're adding together to react or between more than one product. And the other thing, the most important thing to me that everybody always gets wrong is this. It's always, always an arrow, never an equals. So loads of people will write magnesium plus oxygen equals magnesium oxide. And it's not, because an equal symbol means kind of the same as, it's equal to. Now, magnesium is a shiny silver metal. Oxygen is a colourless gas. And when you react them together, what you actually make is a white powder. So they're not the same. They're not equal to each other. And so it has to be an arrow to say these two reactants turn into this product. So you must use an arrow. Some other key features, there's no numbers at all in this word equation. So I've got no little numbers after the chemicals and I've got no big numbers in front. So you don't need any numbers at all. A word equation will not tell you how much stuff you've used or how much stuff you've made. It'll just tell you what the names of the reactants and the products are. So one thing I would say about word equations, if you're in an exam and the question tells you to give the word equation, some people either don't read it properly or think that a symbol equation is better because it's a little bit higher level. But if it asks you for a word equation, you must use a word equation. So please don't try and put symbols in instead. And the other thing people sometimes do, if I give you a slightly different example. So if I do respiration, which is glucose plus oxygen, makes carbon dioxide and water. Sometimes you'll get equations like that and you absolutely cannot do that, because if they've asked you for a word equation, you should not be using symbols. If they've asked you for a word equation, you need to be writing these names out in full, like this. Okay, so be really careful when you're writing word equations. Sometimes they're so simple that you still get the marks wrong because you try and do something a little bit too clever. Okay, let's have a look at symbol equations then. So we'll go back to this same equation of magnesium and oxygen reacting to make magnesium oxide, and we'll look at it in terms of symbols. Okay, so before you can begin using symbol equations, you need to make sure that you understand what a formula means. So we'll just do a quick exercise of looking at some formulae and figuring out what they mean. So if I give you these formulae, which appear in our reaction in our chemical equation for this substance. We have got Mg. So you need to know what Mg actually means when it's written out. Now, because there's no numbers at all on this, the number of atoms involved here, there's just one. So we've got one atom, and it's because there's only one atom, there's only one element, and that name of that element is magnesium. Okay, your second one down, O2. Now the number of atoms, we've actually got a number here. So we've got O, but we've got it twice. So there's actually 2 atoms here. So you can consider it to look kind of like a little molecule like this. So we've got 2 atoms, but we've only got one element, because if you were to name the atoms in this, the only atoms you've got are oxygen atoms. So you've just got one oxygen, which is the element, but you've got it twice stuck together in a molecule. And if you were to name it, it's called oxygen. Okay, MgO. Now, I'm going to jump actually. I'm going to look at the number of elements first. So let's go straight for how many elements are in it. When you're using compounds, the thing I would suggest is that you look for any capital letters. So in this one, we've got a capital letter here and a capital letter here. And every time you come to a capital letter, that gives you the number of elements that are in it. So there's 2 capital letters, so there are 2 elements in here. That means we can break it down just here into which elements we've actually got. So on the left, we have got magnesium. And on the right, we've got oxygen. And then I'm going to look for numbers. So little numbers like this one here. Have we got any here? There are no numbers in this formula whatsoever, which means that we've just got one of them and we've just got one of them. So there are 2 atoms. So if you drew it out, you might draw something like this, where we've got a magnesium and an oxygen. It's actually a little bit more complicated than that in this particular example, but there's 2 atoms involved here, just within the formula. Okay, if you go on to do ionic bonding, you'll realise that this is actually quite a simplified version of what we've actually got here, but it'll do for now. It'll help us to figure out what we've actually got in each formula unit. Okay, so let's do just a couple more examples. So if I give you, we'll go for something a little bit more complicated. So we'll go for H2SO4, that's sulfuric acid. Again, I'm going to do the number of elements first. So how many capital letters have we got in it? We've got one there, one there, one there. So there's 3 different elements in it, and we can name them. So this one here is going to be hydrogen. You can use a periodic table for this. This one here is sulfur, and this one here, O, is oxygen. Now the number of atoms that are in it, if we just remove some of this, let's have a look. So our H's, in terms of how many we've got, there's a little 2 after the H, so we've got 2 H's. There's nothing after that one, so we've got 1 sulfur, and there's a 4 after the oxygen, so we've got 4 oxygens. So we have got 4 plus 1 plus 2, we've got 7 atoms in here. Okay, 2 of them are hydrogens, 1 of them is sulfur, and 4 of them are oxygen. Okay, we'll do another one. Very quick, just one more example. We'll go for simple one, CO2. How many capital letters? We've got 2, so there are 2 elements in it. Those elements are called carbon and oxygen. And how many atoms? Well, we've got 1 of those because there's no number after it. And we've got 2 of those because there's a little 2 after the oxygen. So we've got 3 atoms in total. So if you were to draw out carbon dioxide, it might look something like this. 3 atoms, but 2 different types, so 2 elements. Okay, if you think you can do that, we can start looking at symbol equations now. So we're going to write the symbol equation for the magnesium reacting with oxygen. So as you've just seen in the previous slide, we've got magnesium, which is Mg. We've got oxygen, which is O2, because it's diatomic. Oxygen goes round in pairs. And we've got the formula for magnesium oxide, which is MgO. Now, unless you've done any structure or bonding or anything like that, you won't actually know what the formula of compounds are, so you'll be given them. So you'll have to be told if it's MgO or if it's got any little numbers in or anything like that. So just trust what you're given for that for now. Now, this is a perfectly good symbol equation, but it's not balanced, so we need to take it one step further. What I mean by that is a chemical reaction is when you have got reactants on the left-hand side made up of atoms, and you break them apart and rearrange them and you put them back together in a different order. So I'll draw out some atoms for us so we can visualise that. So here are our reactants in atoms. So we've got the 1 magnesium atom and we've got the 2 oxygens joined together in a molecule. And these are going to rearrange themselves to form our product. So we'll take the magnesium and we'll react it with the oxygen and we will make magnesium oxide. Now the problem is we've got this oxygen atom that is left over and that can't happen. So in a chemical reaction, every atom that you start with has to be there again at the end. So we need to fix this and it's called balancing an equation. Okay, so what we need to do is start with enough magnesium and start with enough oxygen that we're able to make full units of magnesium oxide with nothing left over and nothing gone missing. So what we can do, what I'm going to do is I'm going to put a box around some stuff because I don't want anything to change when it shouldn't. Oxygen's always O2, it comes in twos. So if I change that to O4 or something like that, it's going to be a problem. So I'm going to put a box around it to remind myself that it comes in twos, and magnesium can have a box because it comes on its own as well. And then what I'll also include is some magnesium oxide. So we'll have one of them and one of them to make magnesium oxide. It's not a great diagram for magnesium oxide, but it'll do for now. So we'll put a box around that as well to remind ourselves that magnesium oxide is one of each. Okay, I'm going to put a line down here to say which is my reactants and which is my products. We've got reactants on the left and we've got products on the right. Okay, so what we can do is we could, because we've got 2 oxygen atoms here, we could make more magnesium oxide. So what I'm going to do is I'm just going to repeat this box here. There we go. So now I'm making 2 lots of magnesium oxide, and that's good because we had 2 oxygen atoms to begin with here, and one has gone to this one and one has gone to that one. So we've used up the the oxygen, which is really good. So we're just going to make twice as much magnesium oxide as we did before. But hopefully you can spot another problem now, because although we've got the same oxygens on both sides, our magnesiums are not balanced. So it looks like we've started with 1 magnesium atom and somehow we've magically ended up with 2. And you can't do that. If you've made 2, you have to have started with 2 as well. So what we can do is we could just start with some more magnesium. So at the minute we're only starting with 1 magnesium atom, but I could double that up as well. So what I'm going to do is just repeat that box and put that there. And then what that means is I've started with 2 lots of magnesium and just the 1 lot of oxygen, and I've made 2 lots of magnesium oxide. And now if you check each element in turn, it should balance. So the number of magnesiums on the left is 2, and the number of magnesiums on the right is 2. The number of oxygens on the left is 2, and the number of oxygens on the right is 2. So this is now a balanced symbol equation, okay? This is the working out for it. If you want to write it out properly so that it is balanced, the only thing you need to do is you have to take your original equation and you look at how many times you've drawn each chemical. So the magnesium in the reactants, we've actually had to draw that twice. So I'm going to say 2 lots of by putting a big 2 there. Oxygen, I haven't doubled up or anything, so I can leave that as it is. But the magnesium oxide in the products, I've doubled that up. So we've got 2 lots of magnesium oxide. And that is my final answer. So if you're asked to balance the equation between magnesium and oxygen to make magnesium oxide, the full balanced equation would be 2 lots of magnesium plus oxygen, which comes in twos anyway, makes 2 lots of magnesium oxide. That's how you balance an equation. Now, just to remind you what the numbers mean, if it's a big number, it's how many lots of something you've got. A little bit later on, you might call it moles, how many moles of magnesium you've got, but you can think how many lots of, or how many boxes have you drawn. And the little numbers, they tell you how many atoms are actually inside the box. Okay? So that's what the 2 different versions of numbers mean. And when you're balancing an equation and you're saying how many times you've drawn each chemical out, how many times you've drawn each box, your big numbers must go in front of the thing that you're talking about. When you're talking about how atoms exist, when they exist in pairs, this number must come after the atom that you're talking about. Okay, and that's how we do it. So I'll show you another example, different reaction, and we'll just use the exact same method to balance it. Okay, so let's do another example of an equation. So we'll go for lithium reacts with water to make lithium hydroxide plus hydrogen, which is also diatomic and it comes in twos just like oxygen does. Okay, so here's my method, and this is the method I'd recommend you use. We need to know what's the reactants and what's the product, so let's get a line separating reactants from products so that we can see very clearly what we've got. Now, you can draw them in circles if you want, and you can use different coloured circles like I did in the last example, or very simply, we can just list the type of atoms we've got. So this atom here is a lithium atom, and it's just one, and I'll put a box around that. The next reactant is water, and it's made up of 2 hydrogens and 1 oxygen, and I'll put a box around that. Then we've got lithium hydroxide, which is made of a lithium, an oxygen, and a hydrogen, and I'll put a box around that. And then I've got the 2 hydrogens for H2, and I'll put a box around that. Okay, so in the last example I drew little atoms. You can do that if you want, or if you just want to list what type of atoms you've got, one after the other, that's absolutely fine. And you can put a box around each of them. Remember, the reason the box is there is to stop us from adding in extra atoms that we shouldn't have, and I'll give you an example of that now. So if we have a look at what we've got, we're trying to get, remember, the same atoms on this side of the equation as is on this side of the equation. We've got to get them balanced on both sides. So we choose an element. So let's go for the first one, which is lithium. And on the left, I can see, and I mean the whole left-hand side, so all of this, I've got 1 lithium atom. And on the right-hand side, which is all of this part, I've got 1 lithium atom. So lithium's fine, 1's gone in and 1's come out. So we can leave lithium alone. Let's have a look at hydrogen. Hydrogen on the left-hand side, that's both boxes here, we have got 2 hydrogen atoms. And on the right-hand side, in fact, we'll just note that down, we've got 2 lots of hydrogen here. And on the whole right-hand side, and this is why you have to be careful to check every box, we've got 1, 2, 3 hydrogen atoms. So we've actually got 3 H's on this side. Now, you can't take anything away when you're balancing equations. All you can do is put more in, multiply, and use more reactants or create more products. So we've started with 2 hydrogens, but we've magically ended up with 3. Can't happen, so we need to make sure that we put in more hydrogens on the left-hand side to get it to balance. Now, the reason I ask you to put them in a box is because some people would go, right, I need another hydrogen on this side, so I'll change that and I'll make it H3O. But is water ever H3O? It isn't, it's always H2O, and you can't do that. But lots of people will try to do that first because they think that that's what you're supposed to do. So let's stop us from doing that by putting the chemicals in a box like this to make sure that we've always got 2 H's and 1 O every time we draw that chemical. Alright, so what can we do? Well, we need more hydrogens on the left-hand side in the reactants, so we look at the boxes we've got over here, and we decide which box are we going to draw again to make sure that we've got more hydrogens on this side. Well, if I draw this box again, that's not going to affect my hydrogens, so I'm not going to do that. But if I draw this box again, that would give me more hydrogens. So let's get rid of our working out here, and we'll draw this box again. So let's copy that. There we go. So we now got more hydrogens on the left-hand side. Problem is, we've actually got 4 hydrogens now on the left-hand side. 1, 2, 3, 4. We've still only got 3 on the right-hand side. And that's what happens with balancing equations. Every time you fix one thing, it messes something else up. And some of them can be a little bit complicated where you have to go backwards and forwards, but you will get to the right answer. So just bear with it. It's a bit like a Rubik's Cube. You've got to fix one thing and then fix something else that you've just messed up. So we now need more hydrogens to come out on the right-hand side because we've got 4 going in and only 3 coming out. So I look at the boxes I've got on my right-hand side and I try and choose which box would I draw again so that I've got more hydrogens. Well, actually, there's hydrogen in both boxes, so I could draw either of these again. But it would make more sense probably to draw this box again for 2 reasons. 1, because if I draw this box again, I'll end up with equal hydrogens on both sides because I'll have 1, 2, 3, 4 hydrogens on the right, and 1, 2, 3, 4 hydrogens on the left. So that's a good idea. The other reason is because if you look at your oxygens, you've got 2 on the left, but you've actually only got 1 on the right. So if you draw this box again, it would sort that out as well. So pick a box on the right to draw again. I'm going to pick this one, and we'll draw it again. Okay, so let's stick with hydrogens for now. Hydrogens going in, we've got 1, 2, 3, 4 going in, 1, 2, 3, 4 coming out. So that's really good. Hydrogens are sorted. Oxygen, we have got 1, 2 on the left hand side, and we've got 1, 2 on the right hand side. So that's really good as well. Hydrogens are fine, oxygens are fine. But when we drew this box again, we added an extra lithium in, because when you draw that box, you have to draw everything that's inside the box again. So we had 1 lithium, but we've now got 2. We've only got 1 on this side. So where do we need more lithium atoms? We need more going in so that we can make 2 coming out. So look on the whole left-hand side, choose a box that's got lithium in it, and draw it again. That's that box there. So let's draw that again. There we go. So I draw that box again. And then I check my atoms again to see if we've got the same amount. So let's just do a little tally at the bottom. Lithium. On the left, we have got 2. 1 there and 1 there. And on the right, we have got 2, because we've got 1 there and 1 there. Hydrogen. On the left, we've got 1, 2, 3, 4. And on the right, we've got 1, 2, 3, 4. Oxygen, on the left, we've got 1, 2. And on the right, we've got 1, 2. There we go. So that stayed the same, that's the same, and that's the same, which means this is a balanced chemical equation. Remember, the very last thing that you have to do, and if you don't do it, you won't get the marks, is you have to go back to this original equation and put the big numbers in. So how many times have we drawn the lithium box? Twice. We've got 2 lots of it. How many times have we drawn the water box? Twice. We've got 2 lots of it. Lithium hydroxide, we've got 2 lots of it. And hydrogen we've left on its own, so we're just going to leave that as it is and not put any big numbers in. And that's your final answer. So let's get rid of all of our working out. And there's our final balanced equation for lithium and water. 2 lots of lithium reacts with 2 lots of water to make 2 lots of lithium hydroxide and just 1 lot of hydrogen gas. So that's how you balance an equation. If you're doing it on paper, you need to make sure that every time you decide to draw a box, again, you draw everything that's inside that box, okay? Not just individual atoms, otherwise we'll mess up the formula. But that's how you do it. So now you just need to practice a load of equations to balance. So I'll give you some on the next slide in case you need some to practice, and just follow the same method. If you're not sure, just rewind this video and follow the method that I've used, and you shouldn't really go wrong.